All right, let's continue. And so I put up a nice therapeutic cat picture here. The university where I worked prior to moving to Helsinki, in the psychology department there, they had therapy dogs. And so like when students were stressed out at exam time, the therapy dogs were available so that people could go and pet a dog to like help them relax. And it was my window, I looked straight out to where the dogs were, and so I would be working in my office like watching these people happily petting the dogs. And it wasn't that uplifting for me.
You were dreaming.
But the students really seemed to like it. So this is our virtual therapy cat here, looking very cute.
It's recording.
Yeah. So yeah, if we get back to what we're doing here with functions, what we're going to do now is say goodbye to our therapy cat and go back to Spider, which is maybe the polar opposite of a therapy cat. And we're going to look at how we can take the functions we've just been typing in and save them in a script file so that we can reuse them. One of the really good things to do when you're learning to program is when you figure out how to do something, save it and reuse it. If it's something you think you're going to do more than once, just save it in a file, and you never know when it's going to come in handy. It'll save you a lot of time compared to like going back and saying, oh right, I wrote a function to do this a long time ago. Let me see if I can figure that out again. At least if you're like me, let me see if I can figure that out again. It doesn't usually go that well. So what we're going to do is create a script over here in our Python or Spider editor window. So I'm going to take what we had here from our list examples and just delete all that stuff. And I'm not going to worry for the moment about putting a kind of nice doc string or anything like that up here. Instead, what we want to do is just copy and paste some of the functions we've created. And to do that, we're going to take advantage of another neat little thing in Spider you might not have played with yet. And that's down here in the bottom. I don't know how well you can see the mouse cursor down here, but I'm all the way down at the bottom of the window beneath the IPython console. There's a button here for history log. And if you click that button, you get a history of everything that's been typed in to the IPython console in Spider. And this is basically just stuff we've typed in. You don't see the output, but obviously we've defined a few functions, and what we want to do now is copy and paste them into a script in Spider that will tell us or allow us to use those functions more easily. So we can start by here with our first function we created up at the top called Celsius to Fair. If you have done that and been following along, you can just simply select it, and then you can do edit, copy, or Control-C, whatever you're more familiar with, and then edit, paste, or Control-V. If you're a Mac user, it's Command-C, Command-V to copy and paste. So we have there our Celsius to Fahrenheit function. Just going to do the same thing over here with our Kelvins to Celsius. I'm just going to copy and paste that one. And then do the same thing with the Kelvins to Fahrenheit. Just copy and paste. So nothing new here. We're just taking what we've typed in and putting it into the script here. If you want practice typing the functions in, you're welcome to do that while I'm talking as well. And I'm going to take this now, and I'm going to go up to the little disk, or actually to File, and Save As, because I want to save this temperature converter thing as a script called temp converter, temp_converter. And I'm just going to save that in my home directory. You can save it wherever you please. I've got a lot of junk on my desktop, so I don't want to save it there right now. I'm just going to put it on my home directory for the moment. If you've got a directory for this lesson or something you've created because you're really organized and on top of things, you can certainly save it there. So I've saved temp converter, and at this point I am going to just go up here and make a simple brief doc string. So I'm going to delete the stuff that this says spider editor, blah, 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 and say this script contains functions to convert temperatures from Celsius, Fahrenheit, and Kelvin. And I'm also just going to put my name down here and the date. So it's the 27th of September. You can put things in the format that we suggest in the earlier lessons if you'd like it look a little bit nicer. I can't remember exactly how we formatted things before, so I'm just going to put in this information here, at least including what the function does and who wrote it. And when is also kind of a useful thing to do. So, and I'm just going to save it again. Click on the little disk here. So we have our three functions. And, well, what can we do with them? Well, in order to use them, we're going to create another Python script. So if we save these in Temp Converter, I'm going to click here on the little button for New File. You can also press Control-N or Command-N if you're on a Mac. And here we're going to create something called calculator.py. And first off, I'm going to go up and do File, Save As. And in the same directory where I put this temp converter, I can see it here in my home directory, I'm going to save this script called calculator.py. And it's important, as noted in the lesson, that you save this in the same directory as the other tempconverter.py script. The reason for that will become obvious in just a moment. So I'm just saving it just to kind of get the file name there so that when I make a change and save it again, it saves in the right spot. What do we want to do here? Well, in calculator.py, we want to type in from temp converter, and then import, and then Celsius to var. Does anyone have any idea what this is going to do? No? Yeah. So we have this script file we just saved called tempconverter.py. In there, we have a function called Celsius to var. And when we run this import command, it's basically going to load that function in just as if we had typed it in so that we're able to use it. Which means, oops, don't do that. Which means that here we had previously done something like define freezing point using our Celsius to var function. I'm looking just over at the command history tab again. And then we had printed that out, or we had printed the boiling point of water. I'm just going to copy what we had typed in previously, where we had printed the boiling point of water and paste that into the script here. And I'll make this just a tiny bit wider for the moment since we're not really using the IPython console. So I have this import statement, and then I have the print that's going to use a function called Celsius to far. If all goes well, when I run this code, it's going to look at the temp converter.py script, find the function called Celsius to far, and import that into memory so that we can use that function. So let's test it out. I'm going to save, and then I'm going to click the play button up here on the top. You guys probably already know about the play button in Spider since you're becoming experts in running things in Spider. So when I hit that, I see that my IPython console reappears down here and it says the boiling point of water in Fahrenheit is 212 degrees. That is, in fact, the same answer we got before. So it looks like not only did our script allow us to load in a function from a different file, but it also seemed like it worked. It gave us the answer that we expected. The nice thing about this is that, okay, let's say we know that the boiling point of water is 212 Fahrenheit, or if we go and edit the script and say the freezing point of water, and I put in here 0 with the function, run it again, it tells me that it reloaded the module and that the freezing point of water in Fahrenheit is 32. We knew those values already, but you know, we could put in some other number here, like whatever we want. Let's say, well, what's the temperature today? 12 or something like that? Yeah. So let's put in 12 here and figure out that 12 Celsius in Fahrenheit is. And I'm just editing what I have here because it's in a text editor. It's easy to do these kind of changes here compared to typing it into the IPython console. And if we want to know what 12 Fahrenheit or 12 Celsius is in Fahrenheit, we see that it's 56 or 53.6 degrees. And that, I can tell you, that's about right.
Maybe one kind of important point about importing the functions from a script is that basically when you save your script, for example, we saved the temp converter.py file, but when you import stuff, you don't put the .py to the import statement. So you only use the name of the script that you are kind of importing stuff from, as shown here.
Yeah, that's a good point. And as it's mentioned in the lesson, you know, you can also, if you want to import more than one function at a time, we had our Celsius to far. We also had Kelvins to Celsius. You can list more than one function just separated by commas here. There's reasons why you might not want to do that with maybe more than 3 or 4 functions. But you know, in this case, like let's say you know, you've written this script that has hundreds of functions in it and you only want to use one, it doesn't make sense to load all of them. You can only choose to load a single one. So this would work as well. And this, so if I run this, it doesn't change anything that happens in the code because all I do is just load this Kelvins to Celsius function to be available to be used, but I don't actually use it in this case. So how is this so far? Kind of with me? Yeah? Just a normal new file. Yeah. Yep, nothing special. In fact, this is just the normal stuff that's at the top of the, when you create a file in Spider, it always puts this shebang stuff at the top and the encoding and stuff like that. So, yeah, this is one way we can do this importing individual functions. Now, more often than not, you'll have some script file where you have a set of functions that are all typically used together. So instead of saying like, well, from this file, take a single function or a couple, we could instead, and I'll just comment this out for right now so it stays here. We could do an import temp converter as TC. Now, we'll see, this is a little bit different, but what we've done here is we're going to bring in all of the functions that are in temp converter. And in this case, in order to be able to use them, like for instance here, where we have our 12 Celsius and Fahrenheit is, when we import all of the functions together from a script file, we have to give a name, or it will use this temp converter name. And to use a function that is part of that temp converter, in this case we do tc dot and then the name of the function. This will come up again when we talk about modules in just a moment, but essentially the idea here is that with this form of reading in the functions, we bring in all of them. We could in fact just import temp converter, and all that says is just read all these functions in. But in order to keep things sort of separated, like which functions come from which file, in Python, what would normally happen if you just did import temp converter is to use a function that's part of temp converter, you would have temp converter dot Celsius to far. Does that make sense at all? I mean, it can run the example here. It'll do exactly what it did before. It says 12 Celsius in Fahrenheit is 53.6. If I take away this temp converter part, this may still work. Let me see. Yeah, it does still work. It doesn't. It's because it's yeah. Let me see here.
Yeah.
I'm going to restart my IPython console. The reason why that worked is because we defined this Celsius to Fahrenheit function when we were typing things in the IPython console before. If I restart IPython console, that will basically get rid of all of the previous functions we've typed in. And it takes just a moment, and in this case, crashes. Spider, it looks like. Maybe not. Nope, still alive. Okay, I don't know what happened there. So here, now, if I don't include the temp converter in front of the name of this Celsius to Fahrenheit function and try to run it, it gives me an error saying Celsius to far is not defined. When it imports things like this from another script file, the way that it keeps it separate is to keep the name of the script file around. So to use the Celsius to Fahrenheit function, in fact, you can see all the functions that are available in Spider. When you type in temp converter dot, it shows you here are the possibilities. We have our Celsius to far, and if I run that now, I don't have any problem because basically it couldn't find Celsius to far before because when it's imported with this temp underscore converter part in the front of the name of the function. In some ways, if we remember back to when we played with the math square root and math sine functions in the very first lesson, where we did like math.sine, math.square root, this is exactly the same thing. In that case, in fact, math is basically the same type of thing. It's basically a script file that loads in. We call it a module in Python talk, but We'll see about those in just a moment. But just to make sure, does this make sense? Like why it doesn't work if we don't include the temp underscore converter part? Yeah. So depending on the name of your file, that's the reason why you might want to import temp converter as TC, for instance, because all that does is it just renames what we're going to call this set of functions when we use them. So TC is a lot easier to type in than temp underscore converter, and as long as you know what TC stands for, this is a useful way to do it, where you just rename temp converter to be called TC. So that's where this import temp converter as this new name. That's all that does. So in the lesson on the web page for the course, it goes into things about having additional parameters in your function. So if you have 2 things you want to have in your function or more, that's covered in the lesson. And it's a nice example because you give one number and then one value that's expected to be some character string in order to basically have a check of, is this temperature that comes in Celsius or is it in Fahrenheit before it does the conversion to Kelvin. So you can read about that on the course page because it's a little bit more of an advanced topic and not something that we'll necessarily need for the exercise for this week. So with that, then, we are going to move on to just briefly talking about using modules. It's a different sounding name, but it's actually almost exactly what we were just doing. Before we transition, though, I just want to check, are there any questions about functions at this point? So would you say, maybe by show of hands, that maybe how many of you feel like you could create your own function to do something? Okay, that's good. You get to practice that in the exercise this week. So we'd like to make a point that using functions is a good thing to do, and hopefully, hopefully you'll see why that's beneficial in the future here. So yeah, we're going to just talk about modules just for a moment here. And the reason for doing this is modules are basically groups of functions that have been defined and available for you to use to do common things. So we saw the math module in the very first Python lesson that we did. So if we go back here to the IPython console for this bit of the lesson, we could type in import math. What that does is it loads a module called math that contains a bunch of functions related to doing mathematical operations. So we can do things like math.square root of 81 and see that we get back the expected value of 9. This basically looks exactly like what we're doing over here when we read in our script file, and in essence, it's the same thing. It's just reading a file with a bunch of functions that are defined. In this case, they're in a file called math.py, hidden away somewhere in your Python installation. But this is an easy way for us to load a bunch of related functions together to be able to do stuff. And as it turns out, in Python, you can find functions to do all kinds of different things. Hendrik and I looked around for maybe some kind of fun examples of things we could do in class. For today, we didn't settle on anything, so we're stuck with the boring math module. But if you want to import modules that will animate text and make it flash different colors, people have written modules for doing that. You can find modules to convert images into ASCII text, and we were looking at an example of doing converting text to spoken language and things like that. There's a whole bunch of different Python modules that exist to do all kinds of different things. We'll use a few of them in this course, but there's many more that have been created. And the cool thing about Python being an open source programming language is that lots of people have created their own modules, and it's always good to go and look and see whether someone might have created something to do exactly what you're trying to do and put it online for free before you start trying to create your own functions.
And basically for all the GIS course, so we will use quite many different modules for doing GIS tasks in the later course.
So, okay, so we've seen here, this is how we load in a module. And just to reiterate, you type the module name and then dot, and then the name of some function that's part of that module to use it. Now, if we wanted to, we could also do just the same as we did with our temp converter. We could import math as m, and then we could do m dot square root of, I don't know, 49. And just like it works if you do math dot square root, m dot square root works just fine here in this case. The drawback here is that you have to remember what m means. Math is not a particularly long word, so more often than not, if you see scripts where people are using the math library, it's usually they just import math and they go with it. We'll see some examples maybe of plotting later in the course, possibly some examples using matplotlib. Matplotlib has a plotting library called pyplot that is part of it, and if you want to use those functions, it's not very convenient to type in matplotlib.pyplot.function name to do something. So people usually just import that as plt, and then you can plt.plot or plt.legend or whatever to create your plots without having to type in this very lengthy name of the library, or the module rather. And again, just to show you the example, we could go with, let's say we had a big module with tons of functions in it, we only want to use one. That's not really the case for math, but from math we could import sqrt, the square root function, and then we can do sqrt of 121 and get the 11 back that we expect here. So when we use matplotlib, this is a common thing to do because matplotlib is gigantic, and if you import everything, it can even take a few seconds for it to load all the functions. And there's an example of doing that. In fact, we can just do it here because it might come up later in the course. But if we do an import matplotlib.pyplot as plt, if you go Googling around for plotting in Python, you're going to find lots of scripts that start with this import matplotlib.pyplot as plt. For the reason, as I just explained, that typing that in is cumbersome. So that loads the matplotlib library. You should, if you've installed Anaconda, you should all be able to do that. And then you can do plt.figure. And in this case, for me, it brings me over here and creates an empty figure window. It should probably do the same thing for you as well if you've installed everything using Anaconda. If you do it on the example on the course webpage, all it does is just output that there was a figure that was created because it can't display a new figure window on the web page. So yeah, just a couple other things here to note about modules. I don't know, I guess, are there questions at this point about what's going on with the modules? Does it kind of make sense? I mean, it's very similar to what we've just done with the functions. So if that didn't make sense, then I can understand this is not necessarily going to make sense, but it seems like I don't see any indications of major problems.
So basically, behind the scenes in Anaconda installation somewhere in your computer, you have basically huge amount of different scripts that we actually import. When we import some module there, what we are actually doing is that we go to the computer, to the Anaconda installation directory, and import some scripts from there and the functions from there. So it's nothing different than that, actually.
Yeah. Okay, so we have this idea now of how to use the functions using to use the modules using the module name .function. If you, for instance, imported something like math, we might want to see, if I just type in math and hit enter, it tells me there's some module named math. If I look at the type of math, I see it is indeed a module. But I don't know what's there. I don't know what's in this math module. What can it do? I know it can do square root because, well, we just saw that. But what else can it do? To determine that stuff, we can do print and then use a function called dir, D-I-R. It's a built-in Python function. And then math. Dir is going to return a list of all of the functions that are part of whatever module you put here, and print is just simply going to print those to the screen. So if I hit enter, I get all this stuff output to the screen, and I see some things here that I expect already. Here's a sine function. That's not a big surprise. Here's a square root we were just using, tangent, cosines over here, degrees and radians. So these are functions that can be useful for converting between degrees and radians, exponential function, factorial. Lots of common mathematical functions are in the math library here. And so, if you wanted to know, for instance, what, I don't know if this will work. We could try 1,000 factorial. This might be too big. Math.factorial. So this should be 1 times 2 times 3 times 4 times 5, all the way up to 1,000. And it's a pretty big number. It does work, but it's a very big number. I'm actually surprised that the computer can represent this number. You can probably make it break if you put in 10,000 or something like that. Nope, it's still just added a whole bunch of zeros, and we've got a very, very big number here. So, if you want to know what 10,000 factorial is, you can do that with the math library, and it's apparently a really, really big number. I thought I'd hit the top of it here, and still going. All right, there we are. So I don't know how many digits that is, but it's big. So anyway, if you don't know what functions are available in a library, you can use this dir function to figure that out. Another thing that's useful is if you want to know how one of these functions works, there's a help thing in here. We've already seen this once before, but just to remind you, you could do help math.factorial. And if you hit enter there, it just tells you the factorial of x is what's going to be calculated, and it finds x exclamation mark. That's the shorthand for calculating factorial. Doesn't show you how that calculation is done, but it just tells you the essential information. And this is basically just coming from the doc string of the function. So I guess we don't really see it here, but in the extra materials for the lesson on functions, there's examples of how to create doc strings for the function that you're using. So actually, let's do it real quick. With our Celsius to Fahrenheit, for instance, in this function, so I've just gone back here to the temp converter for the moment. I don't want to take much more time so that we have some time for Henry to preview the exercise, but if we go back here to our Celsius to Fahrenheit function, some people might not know what this function does. So we can add a doc string that says converts temperature in Celsius to Fahrenheit. And you had some nice example of how to do fancy formatting, so we'll do that just so that we can get some kind of fancy formatting here, down here. So we first state what this thing does. Converts temperature in Celsius to Fahrenheit. And then parameters. So what does this function expect to receive? If you type your doc string in the same way that I'm doing right now, in the same way that's shown in the lesson, Spider does a really nice job of formatting this information for you. So we could say parameters here, well, it's going to be temp Celsius. And I could say that's supposed to be some kind of numerical value. You can type this in if you want, or just kind of watch. This is just, I don't know, bonus material, I guess. And this is going to be a temperature in Celsius. Right? And then here, returns. So what does the function actually calculate for us? I'm going to maybe underline this. Oops. There. And well, it returns, and we'll say it's a floating point number. And this is the converted temperature. And that's it. So I'm just going to then put my three quotation marks to close the doc string. I'm going to save it. And then if I go here, we imported temperature converter as TC. I'm just going to run the script as we did before. It tells me it reloaded the temp converter module. And if I do it down here in the IPython console, if I type in tc.temp, Celsius to far. If I type this in down here as if I'm going to use it, it pops up telling me that it expects something called temp Celsius. We saw that from the way the function's defined. The kind of cool thing here is that if you do Control I, or Apple I, sorry, the command I if you're on a Mac, Control I, with your mouse cursor on the function, this pulls up the doc string we just typed in. And it formats it in this way such that it shows us what the name of the function is, what type of function it is and where it came from, what it does, the parameters, and the values that it will return. This is just purely a kind of nice formatting thing, but if you get used to documenting what your functions do, obviously this is a nice way to be able to see that information, and it's formatted in kind of a pretty looking format.
And this is especially, this becomes more and more important the kind of more professional programmer you are. So the actual, when you are doing programming as a work, people use as much time actually doing this kind of documentation as they are actually producing the actual code. Because we are anyway trying to produce the code for humans, not for computers. So these become more and more important.
Yeah. So that was just to kind of show you how that works, because it is kind of a neat thing to do. I think just the same way that if we wanted to, I could do down here in the IPython console help, and then tc.Celsius to far, and hit enter, and I get the same doc string information that we typed into the start of the function, in when we defined it. So this help explorer thing up at the top in Spider is just formatting the same information in a little bit prettier looking way.
And it works for if you have a module and some function from some module, it works in a similar manner. So
Yeah.
you get
Yeah, that's right. We could do math dot, how about radians? So if I type in math dot radians and I just do, again, Command I or Control I, it pulls that same information up in the little help browser up here. You know, you could type help, but you know, if you like to have things look nicer than just plain text, that little Command I or Control I trick is the way to do that. So yeah, any questions about modules? You can see obviously they're very closely related to functions, and we'll get practice doing that using modules, using functions and stuff like that in the exercise this week. If there aren't any questions, I'm going to step aside and let Henrik give the overview of the exercise.
Yeah, so just a quick overview what kind of things you should do this week. So again, yeah, we have the cat. Sorry, cat. You need to go now. So we have the exercise 4, and as always, what we are doing is that we are practicing the stuff that we went through today. So first of all, what we would like for you to do is to kind of, we are now in the middle of this first period, so this was the 4th one, and we have seven lectures. So what we would like you to do is to kind of give us a little bit of feedback how things are going. So there's a link to this kind of e-lomake form, and there are few questions for you. So we just want some feedback from you how things has been, and if you have had some troubles, how has the pace of the teaching been, and so on. Is there something, yeah, basically any thoughts that you have this far about the course. So we are very, very happy of receiving that. So that's kind of, you don't get any points of that, but we are happy to get some feedback. But then the actual content and the problems. So again, we have 3 different problems, and the problems go in a kind of manner that you need to solve the first one before you can start the second one and third one. So we are kind of slowly building the different building blocks, and actually we end up doing something with the thing. So basically the first problem is something that we already kind of saw during the lecture. So in this one, you need to kind of create a script called functions.py, and there you need to again build this and create a function called far to Celsius. So something that you saw during the lesson. And there is this formula that you should use to kind of convert the temperature from Fahrenheit to Celsius, and basically return the value. And then there are some questions that you should answer, and this is basically, if your function is working well, you should end up having this answer. So it should be pretty much just repeating the things that you saw during the lesson. And then there are some questions for you. You also get some points out of those, so you might want to give a couple of more minutes to answer those. Then the problem 2. Again, we kind of take things from last week's exercise when we kind of classify temperatures. So we do the same thing again, but now instead of kind of creating or using the conditions inside the for loop, now we are actually doing a function, and you should use that function to do the classification of those temperatures. So there is a little bit different. So now you should kind of give and return different class values. So if the temperature is below 2 degrees, you should return a value 0. If it's between -2 and
and +2, you should return value 1. And there is a footnote here that basically says that -2 and +2 should belong to this class. So this is something that we mentioned in the start of this lesson, that this is something that you need to consider when doing the condition. So, but anyway, pretty much the same stuff than last week. And you should create this function called temp classifier that should take the temperature as Celsius decrease as an input and then return those class values. And then the third problem kind of brings these two problems together, and now we create a new script called Temp Analyzer, and there we basically start using those functions that we created in problem 1 and problem 2 and analyze some data. And basically, what is the data that you analyze? So there is this data.py that looks like this. So there is another Python script called like this that contains some values. So you have a list called temp data that has a bunch of Fahrenheit temperatures measured from Malmö airport. And what you should do is to actually import this data to your other script. Let's go back. Where is it? So you should import that data to this temp analyzer, and how you import that is basically in a similar manner as you would import a function. So you can import functions from another script, but also you can import some variables that are defined in another script. So it works just the same. And then what you need to do basically is to first convert these Fahrenheit temperatures to Celsius, and then basically classify those Celsius temperatures to these 4 different classes. And because this temperature classifier only accepts Celsius temperatures, so you really need to do the conversion before you can use this one. So we kind of have 3 steps that we need to do. So read in the data, convert the Fahrenheit temperatures to Celsius, and classify the converted temperature using temp classifier function. So pretty straightforward, and you should get practice of how to define functions and how to actually use them in another script and import stuff. So that's basically more or less. We have a couple of questions here as well. So basically we want to know how many temperature values there are within different classes. So basically what you need to do is to count how many zeros, how many ones, and how many number 2s you have in this list that you create here. And you can use the count function. There's a link to some more information about it. And as typical, there are hints. So there's a link in the beginning, and there are a couple of hints showing what, basically giving you help about how to tackle the problems here. But that's it for this week's exercise. So I hope you enjoy it.